so tomorrow we're going to be working on a collision lab, and we're going to be taking two physics cars and we're going to collide them. But instead of colliding them together, we're actually going to do the opposite of a collision, which is called an explosion. So we're going to be having two cars at the beginning that are going to be touching each other. And these cars have a spring mechanism built in, so you kind of compress it, and then all you have to do is touch it and the spring will let go and the two cars will fly apart. So this is called a mechanical explosion. It's not like a fireworks explosion that has a chemical explosion. This is a mechanical explosion. So we're going to be taking the spring that's going to be compressed and letting it go, and it's going to go flying apart. Similar to like a ballpoint pen. Have you ever had a ballpoint pen explode on you? Not the ink, but the tip will explode and the spring will go flying across the room. So it's similar. So we're going to place these two cars that are going to have the exact same mass on one of our non-friction tracks. And we're going to place these bumpers on either side. Okay? And what we're going to do is we're going to decompress this little spring mechanism, and the cars are going to go in opposite direction. So our before situation is going to be these two cars just sitting at rest. So the initial velocity here is 0, so the initial momentum is 0. And in this case, because we have a track that's going to keep them on the track, our momentum is only going to be in one dimension, and that's going to be the x-axis. So now both these cars are going to go in opposite direction. This car A is going to have a velocity A final. This car B is going to have a velocity B final. So if you look at the convention of this being plus and this being negative, this has a negative VA final, this has a positive VB final. So if we use our conservation of momentum equation, we know that the conservation of momentum states that the momentum before the collision or the explosion has to equal the momentum after. Okay, so we know that before it's 0 because the velocity is 0. Both cars are at rest. And after is going to be the mass of car A times the velocity of car A in the final, and plus the mass of car B times the velocity of B final. Okay, if we move this over here, we have this negative over here, and if you look here, VA is negative, so we have a negative times a negative, which means that the momentum of car A has to equal the momentum of car B. Now, if the masses are the same, what's that tell us about the velocities? The final velocities will also have to be the same. So that's what we're going to be working on for tomorrow. Okay, as we're going to be looking at those velocities, what happens in the after effect of the velocities. Well, now, if we remember back from our first chapter in kinematics, we know that the velocity with a constant acceleration is equal to the change in x over the change in t, which is going to be your distance over your time. So in the effect of the lab that had the two bumpers over here, one is over here, and if this is our 0 point, this delta x is right over here. This is what we're talking about. Okay, so this would be the x of car A, and this will be the x of car B. This is the distance that it's traveled. So if we replace this velocity of delta x over delta t in for the v, we're going to say that the negative mass of the car A times the change in distance, which is this, over the change in time equals the mass of car B times the change in distance of car B over the change in time in car B. Now, if we make the assumption that the time that it takes car A to move this distance and the time that it takes car B to move this distance are equal. So this is what the key to the lab is that this time have to be equal. Okay, then we can say that this will fall out, and this, because if they're equal, then we can say that the mass of car A times the distance of car A has to equal the mass of car B times the distance of car B. Well, the mass of car A and B is going to be set. We're going to change that purposely, and then the distance is what we're going to be worried about. Okay, so the masses can't be negative. We know that. You can't have a negative mass. So our distance is negative. So if we remember here from our convention of this being the y and this is the x-axis, this is a positive, this is a negative. So if we put a negative in here, mass times acceleration, mass of car A times the displacement of car A, negative times negative would be a positive. Okay, so what we're going to do is we're going to set the lab up by trial and error. We want to make sure that our times are equal. One way that we can find that our times are equal is when we release these two cars and they go in opposite directions, we're going to listen to when they hit the bumper. So when they hit the bumper at the same time, then we can work and find out our displacements. The way that we can find out if they hit the bumper at the same time is when they make that same sound at the same time. So we're going to hear boom, boom. That would not be the same, but if we hear boom together, then we know that they've hit at the same time. Okay, so we're going to be using our listening skills to know when the carts hit the bumpers at the same time. From that, we're going to move these bumpers around so that we get them to hit at the same time. Once they hit at the same time, then we can measure our delta x and we can find these answers. Okay, so we're going to be measuring delta x of car A and delta x of car B. And we're going to compare these values to the values that we figure out algebraically by knowing this information. Okay, so what we're going to do is we're going to set up the track with two cars. This is kind of the procedure. We're going to make sure that that spring mechanism is compressed. You're going to place the bumpers equidistant from the two stationary cars. So our first trial is going to be the same cars with the same exact mass and the same distance apart. So we're going to test it to make sure that we hear them hit at the same time. Okay, so what you're going to do is you're going to release the spring compression and listen for the sound of the hit by the cart and the bumper. Now what we're going to do is after you get that set, we're going to add a known value of mass to only one of the cars. So on car A, right here, we're going to add some more mass to it. So car A and car B are going to have different masses on them. Okay, so no longer are A and B going to be equal. Okay, then what we're going to do by trial and error, again, you're going to move these bumpers until they sound the same time. Okay, when they hit the same time. Now in this case, XA and XB are not going to be equal. Okay, because you're going to have more mass on A. Okay, so when the spring is compressed and it's released, you're waiting till you hear them hit at the same time, then you're going to measure the distance for XA and XB. You're going to repeat this steps 3 more times with 3 different masses. So you're going to keep changing the mass of A and making sure that A and B have different masses. Okay? And then what you're going to do for tomorrow, what I need you to do is come into class prepared. Okay, so the first part of our lab is going to be, you're going to have to create a table, and this is not going to be hand done. You're going to have to do it on Excel spreadsheet or some type of spreadsheet. You're going to create a table, and this is going to be worth 10 points of the 50-point lab. So this is a 50-point lab, which is equivalent to 1 quiz. Not a test grade, but a quiz grade. So you're going to be spending a little bit of time on this. You're going to have your trials. Trial 1, 2, 3, 4. Altogether, there's 4 trials. The first one is going to be with no masses and equidistance, and then 2, 3, and 4 are going to be done with changing your masses. You're going to have here the added mass of car A, the added mass of car B. You're going to be measuring your distance of A and your distance of B. So the first trial, you're not adding any masses. Okay, so you're going to have you're going to have 0 over here, and your distances should be fairly similar. And of course, in a trial and in a lab experiment, they're not going to be exactly the same, but there's going to be close because you're going to have some sort of error. Then you're going to be adding masses to each one of these cars, different amounts of masses, 4 times, and calculating and measuring these distances. Okay, so tomorrow you're going to come in ready to do the lab. The only thing that you have for the assignment is to create this table. This is going to be the table that you're going to be handing in for your final lab that's going to be due in a couple days. And we'll go over the rubric for the lab tomorrow in class. We'll see you tomorrow and get ready for some collisions and explosions.